Hi guys, welcome to my video. This is a little bit different from what I'm usually doing. This is almost like an overview of what I did within this video. So what we're doing here is we're going to create an enemy state. So we're going to go between two scripts. So we're going to go through our enemy patrol script and we're going to go to an enemy AI script, which will use an enum state of patrol and chasing, and we'll jump between those scripts, disabling and enabling each other once the player has been detected. We're going to be using state machines, which will control this, and also using raycasts and vision cones to detect the player. Then we will transition between those states and go to our animations. We first put in our enum state, which we put in outside of the model behavior. The main reason for this is that it can be detected by another script. We then go and create an enemy AI script. From here, when we implemented our enemy AI script, we obviously needed our default state. So we needed to state the enemy and the patrol script so we can flip between both of them. Obviously, we then had public variables of the transform of player, a speed because we're disabling the other script, so we need a speed for this script as well. And we also need the animator and sprite renderer, so we can go between those two states within the animation states and also flip the sprite renderer as well. Within start, we called up the animator and the sprite renderer, and we also made sure that we can find the game object, so we did a null check for our player. Within update, we made sure we wrote the reference of the text player and made sure that the text player was the state of chase, and or else we would be patrolling. Once we did that, probably the hardest part of the script putting together was the raycast transform and the 5 raycasts that come a part of it. What I did initially was create a vision range, so how far can the player see, or how far can the enemy see, and then the vision angle, so at 45 degrees, and then how many rays would there be. So I decided to do 5 rays, and that was 5 rays divided between the 45 degree angle. To create this, you can create, obviously we use the angle offset for the maths.f.lerp, and then we divided that by the number of rays. And you could have had the angles for that as well. And we then had the raycast hit 2D, which is a standard raycast, physics 2D raycast. We then did the debug ray for the we did a draw ray so we could see the physically within the game. We could see how far the raycasts were stretching out. Obviously, this won't happen on build or in play, but you'll be able to see this within the scene of your game. We then had to do a null check to see if we did find the player. If it was true, we returned to chase the player. If it was false, we then returned back to detect the player as well. The chase player was dealing with the animation states, so we dealt with that between using a ball of is running. So we went from idle to attack, is running is true, and then we went to running to idle, which obviously is running would then be false. Again, we then did the transformed opposition or move towards, and then we went from there. Once we did this, I then decided to put all the animations together. Luckily, the run animation was already implemented in. I just had to resize the sprites, as you can see I'm doing here in a very quick fashion. Again, as I said, we only used one ball of it is running to go between both animation states. I didn't want to overcomplicate it. So again, idle to running is true, and the vice versa is running is false, which was really quite simple to put together as the script was already there, which is really, really good. I then tested out my scene, and as you can see here, the raycasts were on the wrong side. When I had programmed my player was facing right, but I didn't realize that my enemy was facing left when I programmed it in. So I had to go in and fiddle with some things Pretty much it was fiddling around with the transform right, because that's the way we're facing, or that's the way with the Raycasts were facing, and I had to flip them. But when I flipped them, I flipped the sprite as well, so I had to go in and create a new variable of base direction, and that base direction and automatically flipped the Raycasts at the start, so it was in line with the Raycasts, and then that base direction then took both values and flipped them both together. So that really helps me out. From here, you can see that this did indeed fix the problem. I've got a bit of a weird idle animation there, but the main implementation of the flipping of the Raycasts and the draw call as well was really cool. And at the end, we could see that it triggered really nicely, and the enemy was chasing me with his run and flips the right way, because obviously I fixed it with the base direction implementation as well. If you enjoyed this video, you can grab the scripts right down at the bottom. Thank you.